Hello and welcome back to The Cozy Dreamer. Before we begin tonight's journey, if you find yourself drifting off peacefully, if this becomes a place you return to, I'd love for you to hit subscribe and tap the little bell beside it. That way I'll be here waiting for you again tomorrow night and every night after that. A new story, a new journey, something to look forward to as you close your eyes. Thank you for being here. Now, let's go somewhere wonderful. Close your eyes. Take a slow, deep breath in through your nose. Hold it gently for just a moment and let it go. Feel the surface beneath you, the weight of your body settling, the warmth of the air around you. There is nowhere you need to be right now. Nothing that needs solving, nothing that needs deciding. The day is done, and it is asking nothing more of you. Tonight, we are going on a journey, a quiet one you can take from exactly where you are, without moving a single muscle. We are going to leave this world behind, gently, slowly, the way a dream takes you, and travel outward, into the extraordinary silence of space. Together we will pass the ancient face of the moon. We will fly past Mercury and Venus, the scorched and shrouded worlds closest to the sun. We will gaze into the fire of the star that gives us life. We will drift through the rust-coloured wilderness of Mars, through the floating rubble of the asteroid belt and into the realm of the giants. We will stand in the shadow of Jupiter's storms and circle moons that hold oceans beneath their ice. We will pass through the impossible rings of Saturn, breathe the haze of Titan, and travel out to the cold and tilted giants at the edge of what we know. And we will reach the very frontier, the place where our star's influence finally gives way to the dark between the stars. You don't need to hold any of this information. You don't need to remember anything. Simply let the words wash over you like water. Let your mind follow them as far as it wants to, and then let go. Take one more slow breath. We start here, in this room, on this planet. From where you're lying now, the Earth feels enormous, solid, permanent, a world of oceans that stretch beyond the horizon, of mountain ranges that took millions of years to rise, of forests so vast that you could walk for months and never reach their edge. But pull back far enough, and the Earth becomes something else entirely. In February 1990, the Voyager 1 spacecraft had been travelling for over 12 years. It was more than 6 billion kilometres from home, further than any human-made object had ever been. Scientists turned its camera back towards the inner solar system one final time before switching off its imaging equipment forever. And there, in the darkness, suspended in a beam of scattered sunlight, was a tiny point of pale blue light. 1 pixel. Barely that. This was the Earth. The astronomer Carl Sagan looked at that photograph and wrote some of the most humbling words ever put to paper. Our planet is a lonely speck in the great enveloping cosmic dark. In our obscurity, in all this vastness, there is no hint that help will come from elsewhere to save us from ourselves. The Earth is the only world known so far to harbour life. Think about everything that has ever happened on that pale blue dot. Every war and every peace treaty, every great work of art ever painted or written or sung, every moment of love and grief, of triumph and loss, every person who ever lived out their entire life, kings and farmers, philosophers and children, all of it happened on this one small world, orbiting one ordinary star in one quiet corner of one average galaxy. Right now, as you rest here in the dark, the Earth is turning, slowly and silently, as it has for 4.5 billion years. On the other side of the globe, the sun is rising, Someone is watching it from a hillside. Someone else is brewing tea and looking out of a kitchen window. And here, on your side of the world, the night is quiet and the stars are out. Feel the earth holding you right now, its gravity gentle and constant, a silent embrace that has never once let go of you. And then, gently, we rise. As we leave the blue curve of Earth behind, the moon comes into view. She's larger than you might expect from the ground, a whole world of grey stone and craters and ancient silence, sitting some 384,000 kilometres away. Close enough, in cosmic terms, to feel almost neighbourly. The moon was born from violence, around 4.5 billion years ago, when the solar system was young and chaotic, when collisions between young planets were commonplace. A body roughly the size of Mars struck the early Earth. The impact was catastrophic. It melted both worlds, sending vast clouds of molten rock and vapour spiralling outward into orbit. Over millions of years, this debris slowly gathered itself together under its own gravity, and so the moon was born. Our companion ever since. She has changed more than most people realise. When the moon first formed, she orbited much closer to the Earth, so close that she would have appeared 3 times larger in the sky. The tide she raised would have been monstrous, kilometres high, sweeping across everything. But slowly, over billions of years, the moon has been drifting away from us. Even now she retreats by about 3.5 centimetres every year. In a few billion years she will be too far away to cause total solar eclipses. That perfect fleeting coincidence where the moon fits precisely over the disk of the sun. We live in the one era in Earth's long history when that is possible. A rare gift. Without the moon, our world would be unrecognisable. Her gravity steadies the tilt of the Earth's axis, giving us our stable seasons, the reliable cycle of warmth and cold that allowed life to take hold and diversify. Without her, our axis might tumble chaotically, sending our climate into wild, catastrophic swings. And once, just once in all of history, a human being stood here. On a July evening in 1969, Neil Armstrong descended the ladder of the lunar module and placed a human footprint in the ancient dust. He said, across 240,000 miles of silence, that it was one small step for a man, a giant leap for mankind. 12 people in total walked on this surface. The last was Eugene Cernan in December 1972. Before he climbed back into the spacecraft, he paused, crouched down, and traced his daughter's initials in the dust. TDC. Those initials are still there. The moon has no wind, no rain, no weathering of any kind. A footprint left on the lunar surface will endure for millions of years. Somewhere up there, in the grey and silent wilderness, those 3 letters remain. We drift past quietly, respectfully, and move on. Closer to the sun than Earth lie 2 worlds that are rarely spoken of as destinations, and yet both are extraordinary in their own strange way. Mercury is the smallest of the 8 planets, a battered, cratered world not much larger than our moon, baked by solar radiation and scorched by temperature swings that would destroy any life we know of. During the day, the surface reaches over 400 degrees Celsius. At night, because Mercury has almost no atmosphere to trap the heat, it plunges to negative 180 degrees. Mercury moves faster than any other planet. Its year, one orbit around the Sun, lasts just 88 Earth days. It races, it burns. It has almost no atmosphere, no weather, no seasons. just bare rock and ancient craters and a surface that has barely changed in billions of years. And yet Mercury hides a secret. Deep in its shadowed polar craters, places where sunlight never reaches, even on a world so close to the sun, there is ice, water ice, preserved in the permanent darkness. A small, quiet miracle in one of the most inhospitable places in the solar system. Venus is different. From Earth, Venus appears as the brightest object in the night sky after the moon, a brilliant, steady light, beautiful enough to be mistaken for a star. Ancient mariners called her the evening star, the morning star, a beacon. Up close, Venus is perhaps the most alien world in our solar system. Its atmosphere is almost entirely carbon dioxide, nearly 100 times denser than Earth's. The pressure on the surface is equivalent to being nearly a kilometre underwater. The sky is a permanent thick orange smog of sulfuric acid clouds that circle the planet faster than the planet itself rotates, and the temperature, 465 degrees Celsius, all day, all night, at every latitude, the hottest surface of any planet in the solar system, hotter even than Mercury, despite being further from the Sun. The atmosphere has trapped the heat so completely that nothing escapes. Scientists sometimes call Venus Earth's twin. They are almost identical in size, almost identical in mass. They formed from the same material at the same time, and yet Venus became an inferno, and Earth became paradise. No one knows for certain why. Perhaps Venus received slightly more solar heat. Perhaps it lacked the water needed to absorb carbon dioxide from the atmosphere. Perhaps it had no plate tectonics to cycle carbon back into the ground. It is a reminder, in the vastness of space, of how rare and fragile the conditions for life truly are. Ahead of us, filling the dark with impossible light, the sun. From Earth it appears modest, a familiar disk, warm and golden, but nothing could prepare you for what it truly is. The sun is so vast that 1 million Earths could fit inside it with room to spare. If you could hollow it out and pour in all the other planets, every one of them, it would still be less than a third full. Our star dwarfs everything else in the solar system by an almost incomprehensible margin. At its surface, the temperature is around 5,500 degrees Celsius. That is the cooler outer layer. In the corona, the wispy halo that surrounds the sun and is only visible during a total eclipse, the temperature inexplicably rises to over 1 million degrees. Scientists are still working to understand why. In the core, where the real work happens, the temperature reaches 15 million degrees. Here, hydrogen atoms are stripped of their electrons and fused together under unimaginable pressure to form helium. This process, nuclear fusion, releases vast amounts of energy. It is the same process that powers every star you've ever seen in the night sky. Every second, the sun converts 600 million tons of hydrogen into helium, and in doing so, 4 million tons of that mass is converted directly into energy, radiated outward in every direction as light and heat. The light that warms your face on a summer's day was born in the core of the sun, but it didn't travel straight here. First, a single photon of light in the solar core might spend tens of thousands of years, sometimes even 100,000 years, bouncing through the dense plasma of the sun's interior, absorbed and re-emitted, zigzagging its way towards the surface. Then, once it finally escapes into space, it crosses the distance to Earth in just 8 minutes. 100,000 years of wandering through the sun. 8 minutes to reach your skin. The sun has been burning this way for roughly 4.5 billion years. It has enough fuel left for approximately 5 billion more. On the timescales of a human life, it is essentially eternal, and yet it is perfectly ordinary. A mid-sized, middle-aged yellow dwarf star, unremarkable among the 200 billion stars of the Milky Way. There are stars 1,000 times larger, stars so massive they burn through their fuel in only a few million years and explode as supernovae, seeding the universe with the heavy elements, the carbon, the iron, the gold, that worlds and bodies are made of. We are made of stardust. It is not a metaphor, it is chemistry. Onward now, past the blazing sun, back into the cooling dark, and the red world comes into view. Mars. That distinctive rust-red colour, visible even from Earth with the naked eye, comes from iron oxide. Rust. The entire surface of Mars is in a sense one enormous rusted desert, swept by thin winds, scoured by ancient storms. Mars today is cold, dry and quiet. Its atmosphere is thin, barely 1% as dense as Earth's, and made almost entirely of carbon dioxide. The average surface temperature is around -60 degrees Celsius. Any liquid water that appeared on the surface would freeze or evaporate almost immediately. But Mars was not always like this. Billions of years ago, in the first billion years of the solar system's life, Mars had a thicker atmosphere and a warmer climate. Water flowed across its surface. Rivers carved the valleys you can still trace today. Lakes gathered in low-lying basins. There were perhaps even shallow oceans in the vast northern lowlands. Something went wrong. Mars is smaller than Earth, and its core cooled faster. Without a hot, churning core, Mars lost its magnetic field. And without a magnetic field to shield it, the solar wind, the constant stream of charged particles flowing from the sun, slowly stripped away the Martian atmosphere over hundreds of millions of years. The warmth went with it. The water froze, or was lost to space. What remains is extraordinary nonetheless. Olympus Mons is the largest volcano in the solar system, 3 times the height of Everest and so wide that if you stood at its base, the summit would be beyond the horizon. The Valle Marineris canyon system, which slices across the Martian equator, is so immense that it would stretch from the west coast of the United States to its eastern seaboard, and in places plunges 10 kilometers deep. And right now, as you drift towards sleep, a small robotic rover is slowly rolling across the surface of Mars, its wheels turning a few centimeters at a time, its cameras blinking open in the thin Martian morning, its sensors reaching down into the soil, searching for signs of ancient life. A tiny emissary from Earth, alone on a red desert, 300 million kilometers from home, doing what humans have always done, reaching, searching, wondering if we're alone. Mars fades behind us. We press outward. Between Mars and the next great world lies a broad ring of debris, millions of rocks and metal fragments of every size, from tiny grains to mountains, all orbiting the Sun in a loosely defined band. This is the asteroid belt. In films, spacecraft pilot frantically through walls of tumbling boulders, dodging collisions every few seconds. In reality, the asteroid belt is almost incomprehensibly empty. The rocks within it are spread across such a vast region of space that if you flew straight through, you would almost certainly never come within 1,000 kilometers of any of them. Every spacecraft we have sent to the outer solar system passed through the belt without incident, with nothing special to navigate. The total mass of everything in the asteroid belt, all of it combined, is less than 4% of the mass of the Moon. This is the rubble of a world that never formed. Early in the solar system's history, this material should perhaps have accumulated into a planet. The raw ingredients were there, but Jupiter, just beyond, was already enormous. Its gravity constantly stirred the region, preventing the material from settling and coalescing. Every time rocks began to clump together, Jupiter's tidal forces shook them apart again. The asteroids are what remains, ancient fragments, the building blocks of a planet that was never built. Among them, the largest body is Ceres, wide enough that its own gravity has pulled it into a rough sphere. When the Dawn spacecraft reached Ceres in 2015, it discovered something that no one had quite expected. Bright spots glittering in the darkness of its craters. On closer inspection, they turned out to be deposits of salt, left behind when pockets of briny water ice evaporated into the vacuum of space. Bright spots in the cold between worlds. Even in the quiet and overlooked places, the solar system finds ways to surprise us. And then Jupiter. There is a moment as you approach when you begin to understand that the scale of everything you have seen so far, Earth, the Moon, the vast dark between the planets, has not prepared you for this. Jupiter is not simply a large planet. It is a statement, a demonstration of what nature can do when it has enough material to work with. Every other planet in the solar system, Mercury, Venus, Earth, Mars, Saturn, Uranus, Neptune, and every moon, every asteroid, every comet, could fit inside Jupiter with space left over. It is 11 times the diameter of Earth and over 300 times its mass. It contains more than twice the material of all the other planets in the solar system combined. And yet, for all its immensity, Jupiter is not solid. There is no surface to land on. It is an ocean of hydrogen and helium, compressed by its own gravity into states of matter that barely exist elsewhere in nature. Deep enough below the cloud tops, the hydrogen becomes liquid. Deeper still, it becomes a form of liquid metal, a substance that conducts electricity the way copper wire does, generating Jupiter's enormous magnetic field. The clouds themselves are spectacular. Bands of orange and cream and white churning in opposite directions, driven by winds reaching over 500 kilometers per hour. Enormous oval storms dot the surface. Stable, ancient, feeding on the energy of the rotating planet beneath them. The most famous of these is the Great Red Spot, a storm so large that 2 Earths could fit inside it. It has been raging continuously for at least 350 years, possibly much longer. It is, by some measures, the longest-running storm in the known universe. And yet even this titan is changing. Over the past century, the Great Red Spot has been slowly shrinking. Scientists don't fully understand why. Perhaps one day it will fade and be gone. But not tonight. Jupiter does not travel alone. It is surrounded by more than 90 moons, a miniature solar system in its own right. Some are tiny, captured asteroids, lumps of rock barely a kilometre across, tumbling in distant orbits. But 4 of them, the 4 great moons discovered by Galileo in 1610, are worlds unto themselves. Io is the closest and the most violent place in the solar system. Jupiter's gravity pulls and kneads Io relentlessly, like a hand squeezing a rubber ball. This tidal energy heats the interior to the point of constant eruption. Io has more active volcanoes than anywhere else in the solar system, hundreds of them. Sulfur geysers erupt kilometers into the airless sky, painting the surface in vivid yellows and oranges and reds. It is alien and spectacular and entirely, utterly hostile. Europa is different, smooth and white with a surface of cracked ice that resembles the surface of a frozen lake after a warm day. Because that is precisely what it is. Beneath Europa's ice, which may be several kilometres thick, there is a global ocean of liquid water. Not a pocket, not a reservoir, but an entire planet-wide ocean, kept liquid by the same tidal heating that tears Io apart. Only more gently here, more warmly. This ocean has been there for billions of years, in the darkness beneath the ice, far from sunlight, warmed by the flexing of the moon's interior with water and chemistry and time, conditions that on Earth we know are sufficient for life. Perhaps at this very moment something swims in that lightless ocean, a microbe, an organism, something that has never needed a sun because it has never known one. We don't know. We have not yet found a way to drill through Europa's ice and look. But a mission is being planned. One day, perhaps within your lifetime, we will know. Ganymede is the largest moon in the solar system, larger in fact than the planet Mercury. It has its own magnetic field, a remarkable and rare distinction for a moon, and like Europa, it is thought to harbour a liquid water ocean, buried deep beneath its rocky and icy surface. Callisto, the outermost of the four great moons, is ancient and heavily cratered, a record of the solar system's violent early history, written in craters that cover almost every inch of its surface. It too may have an ocean of liquid water somewhere beneath its crust. Water, it seems, is not as rare as we once imagined. Let that thought rest with you for a moment. In the moons of one planet alone, several possible oceans, several possible places where life might be waiting to be found. Further still, and the most beautiful thing in the solar system slowly comes into view, Saturn. Everyone who has seen Saturn through a telescope for the first time describes the same experience. A kind of breathless, joyful disbelief that something so perfectly, extravagantly beautiful can actually exist in the universe. It looks like it was placed there by an artist who had too much imagination and not enough restraint. The rings. They span nearly 300,000 kilometres from edge to edge, roughly the distance from Earth to the Moon, and yet they are paper thin. In most places, no more than 10 to 20 metres deep. If you made a scale model of Saturn's rings the size of a football field, they would be thinner than a single sheet of paper. They are made of ice, billions upon billions of particles of water ice, ranging in size from tiny frost crystals to chunks the size of houses, all orbiting Saturn in a vast, flat, endlessly shifting disk. When sunlight catches them from certain angles, they sparkle like a chandelier. The rings are not eternal. They are geologically young, formed perhaps only a few 100 million years ago, relatively recent in the history of the solar system, and they are fading. Saturn's gravity is slowly pulling the ring material inward. Scientists estimate that in perhaps 100 million years the rings will be gone and Saturn will look like any other gas giant. We are fortunate to live in the brief era when they are here to see. Saturn itself is remarkable in its own right. It is the least dense of all the planets, so light relative to its volume that if you could find an ocean large enough, Saturn would float in it. Its storms are vast, its magnetic field powerful, its day only 10.5 hours despite its enormous size. The Cassini spacecraft spent 13 years orbiting Saturn, over 290 complete orbits, mapping its rings and moons with extraordinary precision. In 2017, with its fuel almost gone, controllers steered it deliberately into Saturn's atmosphere so that it could never contaminate the moons it had studied. It burned up in seconds. Its final transmission reached Earth on the 15th of September 2017. A small, faithful machine that spent 13 years circling a jeweled giant, and then fell into it. Among Saturn's 80-plus moons, one stands apart from all others in the solar system: Titan. Titan is larger than the planet Mercury. It is the only moon in the solar system known to have a dense atmosphere. In fact, its atmosphere is thicker than Earth's, about 1.5 times the surface pressure. The sky on Titan is a permanent hazy orange, thick with nitrogen and complex organic molecules called hydrocarbons. But what makes Titan truly extraordinary is what flows on its surface. Titan is too cold for liquid water. Its surface temperature hovers around -179 degrees Celsius. But it is at exactly the right temperature for liquid methane, and on Titan, methane does what water does on Earth. It evaporates from the surface, forms clouds, falls as rain, carves rivers and valleys, and collects in lakes and seas. The Cassini spacecraft mapped Titan's surface through its thick haze and found vast dark seas of liquid methane and ethane near its poles, some of them larger than the Caspian Sea. It found rivers of methane cutting through plains of ice. It found dunes of organic particles stretching for hundreds of kilometers near the equator. In 2005, the Huygens probe, carried to Saturn by Cassini and released, parachuted through Titan's atmosphere for 2 hours and 27 minutes, sending back images and data the entire way before landing on the surface. It was the most distant landing ever attempted. What it found was a world hauntingly familiar in its geography: rivers, plains, rounded pebbles of water ice worn smooth by flowing methane, and yet utterly alien in its chemistry. Could life exist on Titan? Not life as we know it, not life based on water and carbon in the way Earth's life is, but perhaps a different kind of life. Life built on liquid methane. Life that breathes hydrogen and exhales acetylene. Life that would find our oceans as inhospitable as we would find theirs. The universe may be stranger and more abundant than we've dared to imagine. We travel further. The sun is now so far behind us that it appears merely as the brightest star in a field of many. Its warmth has been replaced by a deep and ancient cold. The ice giants. Uranus and Neptune are the forgotten members of the planetary family, are distant, cold, and barely explored. Only one spacecraft in human history has visited them. Voyager 2, launched in 1977, flew past Uranus in 1986 and Neptune in 1989. No other mission has followed. They remain the least understood worlds in our solar system. Uranus is the stranger of the two. Something, a massive impact, scientists believe, early in the solar system's history, knocked Uranus almost completely onto its side. It now rotates at an axial tilt of 98 degrees, essentially lying flat. Its poles take turns pointing directly at the sun, giving each hemisphere a summer that lasts 42 Earth years and a winter of equal duration. Day and night as we know them barely exist there. Beneath Uranus's bland blue-green exterior, the pressure builds to extraordinary levels. Deep in its interior, scientists believe that carbon, the same element that makes up coal and diamonds, is compressed so intensely that it crystallizes. Diamonds, millions of carats worth, may fall as rain through the interior of Uranus, settling into a layer at its core. Neptune is stormier, more dramatic. When Voyager 2 swept past it in 1989, it found a world threaded with the fastest winds in the solar system, sustained speeds of over 2,000 kilometers per hour in its upper atmosphere. A vast dark storm the size of the Earth, later named the Great Dark Spot, churned in its southern hemisphere. When astronomers looked again years later, it had vanished, replaced by new storms elsewhere. Neptune glows with an almost impossibly vivid blue, a colour caused by methane in its atmosphere absorbing red light and reflecting blue back into space. It is one of the most beautiful colours in the solar system seen in person. And Neptune has a moon, Triton, that orbits in the wrong direction. Every other major moon in the solar system orbits in the same direction as its planet's rotation. Triton orbits backwards. Scientists believe it was captured from the outer solar system long ago, a wanderer pulled into Neptune's gravity and kept. Because of this backwards orbit, Triton is slowly spiralling inward. In perhaps 100 million years, it will come close enough that Neptune's tidal forces will tear it apart, creating a new ring system to rival Saturn's. 100 million years from now, Neptune will wear rings. Beyond Neptune, the solar system does not simply end, it changes. We enter the Kuiper belt, a broad disk of icy objects stretching far beyond Neptune's orbit. Hundreds of thousands of frozen bodies, remnants of the solar system's formation, preserved in the cold like insects in amber. And among them, Pluto. For 76 years after its discovery in 1930, Pluto was called the ninth planet. Then, in 2006, the International Astronomical Union redefined what a planet must be, and Pluto, too small, too similar to its Kuiper belt neighbours, was reclassified as a dwarf planet. Many people felt the decision was unkind. Pluto had held its status for a lifetime. It had a place in the memory of every schoolchild who had learned the planets in order. But the discovery that truly illuminated Pluto came in 2015, when the New Horizons spacecraft flew past it after a 9-year journey across the solar system. What it found astonished everyone. Pluto has a vast, smooth nitrogen ice plain in the shape of a heart. Scientists named it Tombor Regio, after Clyde Tombaugh, who discovered Pluto in 1930. It has mountains of water ice as tall as the Rockies. It has a thin but real atmosphere of nitrogen. It has blue skies at sunset, caused by the same scattering of light that makes Earth's own skies blue. Pluto, small and cold and lonely at the edge of the solar system, has blue skies. There is something quietly beautiful about that. Something that reminds us not to dismiss the small, the distant, the overlooked. Some of the greatest surprises lie in the places we least expect to find them. Further still, past the outer reaches of the Kuiper belt, into a darkness that no spacecraft has ever reached. The Oort Cloud. We have never seen it directly. It may be impossible to see with any telescope we currently possess. We infer its existence from the long-period comets that occasionally fall inward from it, great dirty snowballs of ice and rock, pulled out of their ancient orbits by the gravitational influence of passing stars, tumbling inward on journeys that may take millions of years before they blaze briefly through the inner solar system and return to the dark. The Oort Cloud is thought to be a vast, roughly spherical shell of icy bodies surrounding the solar system at an enormous distance. perhaps 2 light years from the Sun. A light year is roughly 9.5 trillion kilometres. To cross the Oort Cloud would take Voyager 1, travelling at over 60,000 kilometres per hour, approximately 30,000 years. 30,000 years, and yet our nearest stellar neighbour, Proxima Centauri, is just 4.2 light years away. The Oort Cloud reaches almost halfway there. Our solar system's gravitational domain extends to the very doorstep of the nearest star. Here, at the edge of everything we call home, the Sun is just another star among the millions. Cold and distant. Still there, but barely present. And beyond, the interstellar medium, the space between the stars, the vast, mostly empty, extraordinarily cold and dark gulf that separates every stellar system from every other, threaded with clouds of gas and dust, occasionally lit by the death throes of a distant star, silent in ways that no place on Earth has ever been. This is the context of our existence. This is the ocean in which our pale blue dot floats. It is time to come home. We turn slowly in the vast cold dark, and far away, across billions of kilometres of emptiness, we find it, a star unremarkable among countless others, but ours. We begin the long, gentle journey back, past the frozen bodies of the Kuiper belt, Pluto and its blue sky growing small and then gone, past the ice giants with their deep, strange interiors, past Saturn's shimmering rings still catching the light, past the moons of Jupiter, their hidden oceans patient and untroubled in the dark, through the empty spaces of the asteroid belt, past the red dust of Mars, warmth returning slowly, light strengthening. We pass Venus, brilliant and shrouded, Mercury, small and scorched, the moon, silver and ancient and faithful, and then, below us, something extraordinary, a blue world, clouds impossibly white, oceans impossibly deep, green where the land is, brown where the mountains are, and lit, here and there, by tiny clusters of golden light where the cities sleep. Earth, home. We descend gently, down through the atmosphere, through the clouds, down through the night sky, past the stars that you can now look up and name, or almost name, or simply love without knowing, down to the ground, to the town, or city, or countryside where you are, to this building, this room, this bed, you, in all of the billions of kilometres we have just travelled, through all the strangeness and the grandeur and the impossible scale of the solar system, we did not find anything quite like you. A being with a mind that can imagine, that can travel without moving, that can understand things it has never seen. That lies here, in the dark, on a small planet orbiting an ordinary star, and thinks about black holes and moons and the ice of distant worlds. Every atom in your body was once part of a star. The iron in your blood was forged in the core of a sun that exploded billions of years before ours was born. The oxygen in your lungs was breathed out by the first photosynthetic organisms that ever lived. The calcium in your bones was scattered across the universe in the death of ancient suns and slowly, patiently gathered into the world you were born on. You're not a small thing looking up at a large universe. You are the universe looking at itself. Let your body rest now, completely, fully, every muscle, every thought. You've been to the edge of the solar system tonight and come safely home. There is nothing more to do, nothing more to hold on to. The journey is over, and it was a good one. Let your breathing slow. Let your thoughts drift like dust between the stars. You're safe. You are home. Sleep well.